All right, kids. First little video here that we'll try this here. I'm going to get Mr. McQueen to show you how to deal with this. Hopefully what's going to happen is you'll go through the video. You'll be able to do your homework. You can pause and play as you go. And we'll get to the bottom of the content that way as I'm away today. Bear with me. This is the first time I've used this app in a while, so it might be a little clunky, but hopefully we'll get the job done. So we're looking at solving inequalities by addition and subtraction. A couple little things to note here is that when you're dealing with just a regular equation, so I think I'm going to go here just to where the exercises are, and we'll look at number 1. If I go and actually solve this equation, right? And let's say I had t minus 12 is simply equal to 16, okay? Everybody in the room, I think, knows that, I'm going to add 12 to both sides, and hopefully what I get is t is equal to 28. On a number line, that's going to look like one of these. 0 is somewhere on this number line, and my solution is just 1 point on that line, okay? When I'm doing an inequality, and so my solution set would look like this. In your set builder notation here, I'm going to say t is equal to, I'm going to look for answers for t, so t is the set, the line such that, and simply t is equal to 28, one number, okay? When we're dealing with inequalities, instead of just dealing with 1 point on the number line, I'm going to be dealing with one side of the number line. It's going to be a group of numbers, right? So let's give this one a try. I'm going to go ahead and with the inequality now, I'm going to solve it. Same order of operations. I'm going to add 12 to both sides and get t is greater than 28. But the way that translates onto my number line is that I'm going to have that number, 28 here someplace, and then my solution set is all the numbers that are bigger than 28. So that would be shaded in there. Lots of times if you just got a pencil, what you'll do is you'll put a little arrow up like this and go that way. So meaning that if I include, for example, any number that's bigger than 28, 30, okay, and I dump it back into my t here for a check. So if I go 30 minus 12, is that gonna make this inequality true? So I'm gonna get, I'm gonna get 18 is bigger than 16. Is that true? Sure it is. It checks. If I pick a number that's even further out this way, okay, all of the numbers in here are gonna make this original inequality here true, correct? Okay. What if I use 28 exactly, okay, to plug in for this t? Okay, so I'm going to put 28 in minus 12. Is that greater or equal to 16? Well, sure it is. I've got 16 is greater than or equal to 16, so it holds up with that part of the inequality, okay? So when it's an equal to, that means that I have this solid dot that's saying that 28 exactly is part of my solution set, okay? So the way that I'm going to write the set out, so here's my equation way to say it, right? But my solution set for my inequality is going to simply equal, I'm solving for t such that t is greater or equal to 28, okay? So the only differences from what we were doing before when we were just solving normal equations like this, okay, and then now inequalities like this, is that I'm actually choosing which side of the number line of the solution that I found is going to include the numbers, okay? And in my solution, I'm shading an entire area, and in my answer here in the set, okay, I'm going to have inequality showing my answers instead of just an equal sign. Okay, let's try another one over here. See if I can get this thing to move for me. I can. Good for me. Okay, so I'm looking for y here, okay? So I'm going to go and try and isolate for that y by getting rid of this 12. So I'm going to add 12 to both sides. So I'm just going to do one of these so we don't get in the way. So y is less than, now if I add 12 to both sides, I'm going to get 0 there, aren't I? Negative 12 plus 12 gives me 0, okay? So what is that going to look like on my number line? All right, so I know that y is going to be less than 0, okay? So all of the answers that I'm looking for are going to be less than 0. So I'm going to do my little line. Numbers that less than 0 are on the number line are this way, okay? But in this case, there was no equal sign in my inequality. So 0 doesn't actually count as a solution. So the way that we denote that is that we put a round circle around that inequality. All right, so over here, where are we at here? Let's try this again. Because it was an equal sign here, solid dot on my solution. Over here, no equal sign in my answer, right? Okay, just the inequality less than, so that means I'm going to do an open dot. So in my set builder notation, it's saying the solutions for y are such that y is less than 0. Okay, there we go. Okay, let's try one more and see how we do. Oh, look, I did that, yeah. We'll go on to the next page here. Let's see what happens. Yeah, so here we're going to get a couple of word problems. Okay, they're just asking you to do a little bit of reading here to actually form the inequality. Okay, so easiest way that I like to do this one is to find out what we're greater than or equal to first. So here my magic number is 4, negative 4. So I'm going to put negative 4, and then whatever sort of expression that I have on the other side of that, it's going to be greater than or equal to that number. Okay, so the sum of some number, let's call it t, and 6, so plus 6, is going to be greater than or equal to negative 4. So go solve for your t. By subtracting 6 from both sides, you get minus 10. And let's go ahead and find that on our number line. So drop minus 10 in here somewhere. Okay, I see the equal sign. So I know that there's going to be a solid dot there. It's going to be part of my solution. And I want all my answers that I'm going to illustrate now with my line to be greater than negative 10. So which side of the number line is on greater than 10? The right-hand side. So there's all my solutions. So my solution set is I'm solving for t such that t is greater or equal to minus 10. That looks pretty good. Okay, so let's try and do, how about we go to and try and do a little check there. So if I pick a number like this in here, what's a number that's in between negative 10 and, well, I guess infinity is sticking out here someplace, right? Let's pick 1, okay? So just to check, one number on the interval, because if it works for 1, it means it's going to work for all of these numbers, right? So if I check 1,